Let's now take a step up and consider not just this construct, but if we fast forward in the game to this part of the screen, now maybe we have a vertical block as well. And let's just consider for a moment, what about my code needs to change if I want to print 3 or maybe any number of vertical blocks? Like fundamentally, how do I want to change the code? How do I want to change the code? Yeah, I just need a line break where I accidentally almost did earlier, but in this case it would be a good thing. So let me go over there and let me just quickly make Mario 3 by starting at the same point. So Mario3.c, and then let me go down here and change this as follows. Let's make this I is less than n the way it's supposed to be, and just so that if we upload these later I don't forget. And now I'll do a hashtag just because it looks more brick-like. It's not one of those coin things. And now I do this here. I don't think I need this anymore. So let me save that and run make Mario 3. Seems to be OK compiling-wise. Mario 3, number 3. And I get 3 of those. And now I can do maybe 5 of those. That works, and so forth. So there's still an opportunity for improvement here. In case I want to pester the user to actually cooperate, such that if he or she types in -50, I don't want to just like quit. Like I want to yell at them or somehow give them feedback and say like, give me what I asked for. How do I continue to pester a user again and again and again until he or she actually gives me the value I want? I'm sorry? While. So there's different looping constructs, while, and it turns out we could use while or even for, or there's another one as well. And let's consider how we might do this. It turns out that when you want to get user input from someone, you could use for, you could use while, but you'll find that it's a little annoying to use those constructs. Let me just jump to the better way first so that we see one other way. It turns out if you in a program want to do something at least one time, and maybe some more times, you could use for or while, but it's actually a little more straightforward to literally just do it while something is true or while something is true. Now, this is just a placeholder. Let me start to fill in some logic here. So I want to do the following. Do the following while what? If the user does not give me a positive number, I want to prompt him or her again. The curly braces on lines 7 and 9 at the moment connote exactly that. Do this, do this, do this, while line 10 is true. So what Boolean expression, if you will, do I want to type in the parentheses here on line 10 to express the fact, keep doing this until the number is positive? Yeah? So while n is greater than 0, keep doing this. Which one? I heard less than. So OK, so let's rethink this. So while n is less than 0, ask the user for a number. Ask the user for a number. Ask the user for a number. And you know what? This is going to just confuse the heck out of them. Let's be even more clear with our prompt. Give me a positive number, but keep prompting him or her until we actually get a positive number. Now, if we really want to be nitpicky, it's actually not even less than. We're so close. It's less than or equal to. Unfortunately, I don't really remember having a key on my keyboard that's got like an angled bracket and then a line under it, like you might write in math class. So there's a way to do that nonetheless on your keyboard. I actually just do them side by side. This is less than or equal to. This would be greater than or equal to. And so now just get comfortable reading these things left to right. There's no special symbol like you would have in a math book or a homework assignment on paper. So this, I think, says the right thing. Do this while n is less than or equal to 0, which is, of course, not positive. And then down here, the rest of my code, I think, can stay the same. I just have a block of code up here now that's doing something. And you know what? This is where comments start to get useful. Prompt user for a positive number. And now down here, print out that many bricks. So, you know, it's kind of obvious if you just read through the code what I just said. But this helps you if you sort of sleep on it and wake up and you want to remember, why did I do this? Why did I do that? It helps the reader of your code, a colleague, a teaching fellow, and so forth. That's how you kind of start to add comments to your code. Unfortunately, there's a bug, and we're about to hit it. So let me try. Let me go ahead and make Mario 3. Oh, my God. More errors than I have lines of code, it seems. And this one's weird. Error. Unused variable n. And now let me dive in deeper to these error messages, just so you start to notice little clues. So over here on the left is, of course, the file name, as you might have noticed, mario3.c. Then there's a colon and then a number and then a colon and another number. Turns out this is just a very succinct way of saying that in mario3.c, on line 9, at character or column, left to right 13, you've got a problem. At least the compiler thinks. So generally, the character is kind of sort of helpful. It's really the line number that draws your attention to the right place. Somehow, this is buggy. And specifically, the bug is that I have an unused variable n. And then very inexplicably, on line 11, now I have a use of n. So it's unused here, but it's used here. And somehow, the computer doesn't like this. Why might this be? Yeah. Yeah, that's the trick here. So it's a little different from Scratch, where when you make a variable, you can just use it anywhere you want. In C and some other languages, variables only exist in what's called a certain scope. And a scope you can generally think of as just the most recently opened and closed curly braces. So what does that imply here? Well, on line 9, I am on the left-hand side declaring a variable. Hey, computer, give me a variable called n, and it's going to store an int. That's the story we keep telling. But the problem is I am doing that in between lines 8 and 10, curly braces, and I claim today that that means, kind of like Scratch has these the hug the puzzle pieces, in C, variables are treated a little different. If you declare a variable in here, it only exists in here, and you can't use it down here in your code. And so this would kind of seem to be a catch-22. I need a variable, and so I can declare it, but I can't declare the variable there if I want to use it later. Like, it doesn't really seem to be a good situation. So just logically, even if you've never programmed before, if the fundamental problem is that this variable exists only in that scope of the curly braces, how intuitively could we solve this? Yeah? Remove the curly brace? Oh, move the curly braces. Yeah, we could move the curly braces, which is essentially the idea. The catch is the do-while loop really kind of needs them. At least in generally cases, you need those curly braces. But you know what? It's been a while since I typed them, but I do have another pair of curly braces that are sort of outside of, so to speak, my inner curly braces. So I have another scope here that's essentially the whole function called main. So what if I somehow declare my variable out there? And indeed, I can. I can go to like line 7 or even higher, but generally you want to keep it as close to where you care about it as possible. I can type int n, and I don't think I want to prompt the user here, because then I'm going to create the same problem as before, where I'm just prompting him or her once. I want that prompt in a loop again and again and again, potentially. So that's OK. We've not seen this before, but you can declare a variable and then do nothing with it yet. Just say, hey, computer, give me a variable. I'll deal with this later. Just like in Scratch, you declare a variable if you did, and then you deal with it later as you want. Now, this would be a bug still. I can't say, hey, computer, give me a variable n, and then, oh, by the way, give me another variable n. So all I have to do to fix this issue is just don't redeclare it. Just use it. So line 7 says, hey, computer, give me a variable called n that's going to store an int. Line 10, same story as always, except it's slightly shorter. On the left-hand side, it says, here's my variable. Right-hand side says, here's a value we got from the user. Put it from right to left. And so now, because n is declared or created on line 7, it exists within the scope of these outermost curly braces. And now I can use it kind of anywhere I want, including on line 12, which is great, and most importantly, on line 15. So let me go ahead and save this and do make Mario3, hold my breath, good. It actually worked, /Mario3, positive number, I'm going to give you -1. OK, I'm going to give you 0, or fine, I'll give you 3. And now it actually cooperates. And so the do-while construct is still a loop. And Scratch doesn't really have an analog of this. But the do-while loop is still a loop, but it does something at least once. The difference fundamentally, though, is this. If I did this, like while n is less than or equal to 0, if I change this to a while loop, which we saw ever so briefly the other day as just an analog of the forever block in Scratch, if I do this, there's kind of a logical problem. Here's n being declared on line 7, so we're avoiding the scope issue this time from the get-go. But line 8 is saying while n is less than or equal to 0. But what is n at this point? It's like not yet defined. And in fact, as we'll soon see in class, like it has some garbage value typically, some unknown value, remnants of whatever the computer used that RAM or memory for in the past. So this is like literally undefined behavior, it would seem. I don't know if the loop's going to execute or not because I don't know what's in n. So you could hack around this, so to speak. Hacking generally means like kind of sort of figuring out a solution to a problem that might not be the cleanest. And OK, let me just initialize it to like -1,000 because I know that's less than or equal to 0. So it's a hack in that it fixes the logical problem because now on line 8, is -1,000 less than or equal to 0? It is. So now my loop will execute at least once, and it will then change the value of n. But like, what the heck is -1,000 coming from? Like, these kind of inelegant solutions would be horrible, horrible design. Even though it logically gets the job done and it's correct, bad, bad design. And so that's why we started with a better design with the do-while loop. But you'll find there's many different ways to do things. And you might not, certainly in problem set 1 or 2, do things always the right or best way the first time. And that's OK, because with practice and experience, you'll begin to see patterns with which you can solve these same kinds of problems. Any questions on these approximations of Mario? Well, let me do one last one. One last one involving Mario, and kind of like this. I spent way too much time looking for parts of Mario that kind of painted these pictures. And I found this, these additional bricks underground in the fire level. And suppose I wanted to print like a cube of hashtags. So not just a horizontal line, not just a vertical line, but kind of sort of both together. And indeed, you can think of these bricks as exactly that. It's like hashtag, 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 hashtag. Hashtag, 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 and so forth. Kind of like an old school typewriter, printing one line at a time. And if you even remember typewriters, you can actually think of computers and printf as behaving very similarly. You can print something, then do the \n. Print something else, do the \n. So what is a square like this on the screen? Well, it's really just the process of like painting the screen, if you will, from left to right, moving down, left to right, moving down. And how do we do this? Well, what was the type of code we used in order to do something again and again and again? The for loop was the first one. We could use other constructs, but I'm going to go ahead and use the for loop again. Let me save this as Mario 4 as our fourth and final example. I'm going to keep this code up here because I still want to prompt the user for some number of blocks, a positive number at that. And now I don't want to just do this, but let me just see where I left off. Let me go ahead and make Mario 4 /Mario 4, and let's do like a 5 by 5 block. OK, that's not. That's just a column. So I've got to do a little more. Well, it turns out that just like in Scratch, I can take one idea and kind of nest it inside of another. Let me go ahead and do this. How about inside of my for loop that's going from I to n, let me do another one for int. And I don't want to reuse I because I feel like if I use I in 2 places, something's going to get messed up. So I'm going to go with the next one alphabetically, j, which is actually pretty common. So int j gets 0, j is less than n, and j plus plus. And now in here, I'm going to put that brick. I think I need to get rid of this here. And let's see now what happens. So I've got a for loop inside of a for loop. If I go ahead and do make Mario 4, enter, code is compilable. /Mario 4, let's type in 5. I think that's actually like 25 if I really count it out. That's not what I wanted. I wanted a square. So what's obviously missing aesthetically? A new line, but I kind of thought that doesn't go here, right? Because if I do this, just real quick teaser, if I rerun Mario 4 after making that change, now I've just made the opposite problem. So what needs to change? Yeah. Oh, just scratching? OK, what needs to change? Yeah, over here. Yeah, and what line would you propose the printf with \n? Sorry? 21. So like above or below it? Above it. OK, so let me go there. So let me go ahead and printf \n. And now let's see. So make Mario 4 /Mario 4 enter 5. Beautiful. Beautiful. It's not quite a square on the screen because like the hashtags are a little more vertical than they are wide, but that's OK. We've built this sort of approximation of that level too. And now, just for good measure, let me just think about it. This is kind of an oversimplification. Print out that many bricks. So print out this many rows or columns on the outside. And then in here, where we're going with this, print out this many. What should my comment here be? On the tops. Top one is rows? And then down here, this should be columns. And it is. Because on the outermost loop, you've got I, and it's starting at 0, and it's eventually going to 5. But whenever I is 0 at the beginning, it's like the cursor is in the top left-hand location by default on the screen. And then you've got this nested loop, which says, oh, by the way, do the following 5 times. What are you doing 5 times? Hashtag, 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 hashtag. Then a new line. Then I becomes 1. So it's like moving over, then I becomes 1, which means you're now on the second row because you've printed out one of those new line characters.